Have you ever wondered how a simple potato is transformed into the crunchy, golden lays you find in any supermarket? Behind every bag is a process that combines agriculture, precision technology, and large-scale quality control. From cultivation in the field to the moment the package is sealed, each stage is carefully planned to ensure unmistakable flavor, freshness, and texture. The history of Lay's is also the story of rapid growth and strategic decisions. The brand was born in 1932 in the United States, created by Herman Lay, who began selling potato chips from the trunk of his car. At the same time, Charles Elmer Doolin had founded the Fritos Company, dedicated to producing corn-based snacks. For years, they were competitors in a growing market, but in 1961 they joined forces to form Frito-Lay, combining the popularity of potato chips with expertise in other snacks. In 1965, this company merged with Pepsi-Cola, forming PepsiCo, a conglomerate that now operates in more than 200 countries. Under this umbrella, Lay's has grown to become the best-selling potato chip brand in the world. The PepsiCo plant we visited in Europe is an example of automation and efficiency. Designed to operate almost without interruption, it has the capacity to process up to 4 tons of potato chips every hour, spread across 4 simultaneous production lines. This means that in a single day, hundreds of thousands of bags ready for consumption can leave the facility. The plant's design aims to optimize every resource, from the reception of raw materials through controlled frying to packaging and palletizing. In addition, the facility has water recycling and heat recovery systems, which reduce its environmental footprint. The starting point for achieving potato chips with exceptional flavor and texture is not in the factory but in the field. Every bag of Lay's begins with a careful selection of potatoes that meet very specific criteria. PepsiCo does not use just any variety available on the market. It chooses potato types that have shown optimal performance throughout the industrial process, from washing and slicing to frying and packaging. These varieties are chosen primarily for their balanced starch and moisture content, their natural color, the firmness of their flesh, and their ability to brown evenly without absorbing excess oil. Among the most commonly used are Lady Rosetta and Hermes, both developed to provide an ideal combination of flavor, crunchy texture, and visual appeal after frying. These varieties produce slices that maintain their shape, acquire a uniform golden color, and preserve crunchiness for longer. Collaboration with farmers is a central aspect of this value chain. PepsiCo establishes long-term agreements with local and regional producers, ensuring not only a consistent supply, but also the implementation of controlled agricultural practices. The company provides farmers with certified seeds, free of disease and genetically stable, to guarantee that each harvest is homogeneous and of high quality. In addition to seeds, technical advice is provided at every stage of cultivation. PepsiCo experts guide farmers on irrigation methods that optimize water use, balanced fertilization strategies that improve soil performance, and pest control plans that reduce chemical use without compromising crop health. Specialized tools and equipment are also supplied for plant management and harvesting, helping minimize mechanical damage that could affect the final quality. Standardization is key. The potatoes must have a relatively uniform size and shape to facilitate processing at the plant, avoiding waste and ensuring even cuts. A potato that is too small could generate fragments that overcook, while one that is too large might require slicing and cooking adjustments that affect production speed. In terms of volume, the commitment is massive. Each year, PepsiCo purchases approximately 240,000 tons of potatoes to supply its plants. This figure reflects not only the magnitude of the operation, but also the importance of a well-coordinated supply chain. Potatoes are harvested according to a precise schedule that allows them to arrive fresh at the plant, avoiding long storage periods that could affect freshness and moisture content. The potatoes arrive at the plant in trucks specially designed to transport them without causing damage. Since they do not require long storage, they are processed almost immediately, which ensures freshness. Before entering the production line, they undergo pre-washing and grading at the origin, removing stones, clods, and plant residues. At the plant, a water transport system carries the potatoes to the peeling area. This method is not only efficient for moving large volumes, but also helps remove surface dirt. The water used goes through filtering and recirculation processes, reducing consumption compared to conventional systems. Peeling is a key stage of the process, as it must remove the skin without taking away too much flesh. This is important because just beneath the skin are nutrients and compounds that influence the flavor, color, and texture of the final chip. For this, the plant uses an industrial peeling machine equipped with a rotating drum whose walls are coated with abrasive material. This coating provides the necessary friction to strip away the thin surface layer, working with precision to avoid losing inner flesh. The drum operates at a constant speed, and the potato's dwell time is calculated to achieve uniform peeling across all pieces. This method is more efficient than mechanical cutting, as it reduces waste and optimizes raw material yield. After peeling, the potatoes pass through an artificial vision system that uses high-resolution cameras to inspect each one. Dark spots, green areas, indicative of solanine, or damage from impacts are detected. When the system identifies a defective potato, it is automatically removed from the line by air jets or small mechanical pushers. Slicing is a decisive stage in production, as it determines not only the chip's appearance, but also their texture and behavior during frying. For this task, the plant uses industrial high-precision equipment fitted with stainless steel blades specially designed to handle large volumes without losing sharpness or accuracy. These blades, sharpened with specialized techniques, maintain tolerances of up to 1/100th of a millimeter, ensuring uniform slices batch after batch. The blade setup can vary depending on the type of product desired. For classic chips, smooth blades are used to produce flat slices, while for ridged varieties, the blades have a special pattern that creates the characteristic wavy shape. This adaptability allows the same production line to make different styles without long adjustment times. Uniform thickness is fundamental. If a slice is thicker, it will take longer to fry and may end up less crunchy. On the other hand, a thinner slice may brown excessively or even burn. A precise cut ensures that all chips receive the same time and temperature in the fryer, producing a uniform golden color and consistent texture. Before the slices come into contact with hot oil, they go through a high-speed air drying system designed to remove surface moisture left after washing and slicing. This step is essential for two reasons. It improves process safety by reducing splattering during frying and optimizes the final result by shortening the time the chips need to remain in the oil, preventing them from absorbing excess fat. Once dry, the slices go straight to the industrial fryer, where high-quality sunflower oil is used. This oil is ideal for its neutral flavor and its ability to withstand high temperatures without degrading quickly. Frying temperature is kept constant, generally around 175 degrees Celsius, thanks to an automated system that regulates both the heat and the exact time each batch remains submerged. Throughout the process, control sensors monitor the oil's temperature and quality, detecting variations that could affect flavor or texture. In addition, the fryer is equipped with a state-of-the-art visual inspection system that photographs each slice in real time. This allows verification that browning is uniform and that there are no burnt or off-color pieces. At the end of frying, the chips are removed from the oil by a draining conveyor belt, allowing excess fat to drip off before moving to the next stage, ensuring a crunchy, light product with the quality that defines the brand. After leaving the fryer, the chips are salted automatically by precision dispensers. The amount of salt is adjusted according to the recipe and the market for which the product is intended. For flavored varieties, the chips go into rotating drums where seasoning mixes are applied. These formulas can include spices, dried herbs, powdered cheeses, plant extracts, and natural flavor enhancers. The residual heat helps the seasoning adhere evenly. Once seasoned and ready for packaging, the chips go through automatic weighing, a key process to guarantee that each bag contains the exact amount indicated on the label. To achieve this, industrial high-precision scales are used, equipped with multiple trays that work in coordination. These dosing trays receive small portions of the product and, through a computer-controlled system, combine the necessary amount to reach the target weight with a minimal margin of error, thus complying with weight and quality control regulations. After weighing, the chips are carefully deposited into the packaging line. The material used for the bags is usually a multi-layer metallized film designed to protect the product from factors that could reduce its freshness and quality, such as humidity, oxygen, and light. This material acts as a barrier that prevents oxidation and preserves crunchiness throughout the product's shelf life. Bag filling is synchronized with the weighing system to avoid jams or tears. Once the bag is loaded with the exact amount of chips, it goes to the sealing station. Here, a controlled heat system seals the top, creating an airtight closure that blocks air entry and prolongs freshness. Afterward, the sealed bags are individually cut and placed on conveyor belts that take them to the final packaging stage. At this stage, the bags are grouped into cardboard boxes that make handling, storage, and transportation easier, leaving them ready for distribution to various points of sale. Once the bags are sealed and grouped, they are neatly placed into sturdy cardboard boxes designed to protect the product during transportation. These boxes are moved to the palletizing area, where automated robots stack them precisely on standardized pallets, optimizing space and ensuring load stability. The full pallets are taken to temporary storage, where they await dispatch. From there, internal logistics coordinate loading onto distribution trucks bound for multiple destinations. Each day, more than 100 vehicles leave the plant, ensuring the supply of supermarkets, stores, and distribution centers throughout Europe. The production level is remarkable. Nearly 100 million bags of chips are produced annually at this facility, each one having passed strict quality controls at every stage, from raw material selection to final packaging, thus guaranteeing a uniform, safe product ready for consumers. What might seem like a simple snack is, in reality, the result of a highly sophisticated industrial process that combines agriculture, food processing technology, automation, quality control, and large-scale logistics. The next time you open a bag of Lay's, behind every crunch will be months of coordinated work, technical decisions, and an optimized supply chain to deliver the product fresh and in perfect condition.